2, and 3. Okay, so you get to select, okay? I just need somebody to select 2 of the 3 equations. So somebody wanna go ahead and make a selection? Now, please note, your selections, right? You should be looking at the before you just choose something, you wanna look at what you have, and you wanna look to see if the things that you pick will have something that cancels out, okay? So it's best if you can pick something where things cancel out. So take a look here. Anybody want to give it a go? You really can't be wrong, but it's just a matter of you're going to make more work for yourself if you pick things that are tougher. So I'll let somebody go ahead and select. So go ahead. Again, you could pick 1 and 2, 2 and 3, 1 and 3. So somebody go ahead and select something.
1 and 2.
1 and 2? Okay.
Yeah.
So let's take 1 and 2. So we're going to take 1. We're going to take 2. Statement 1 is x. This is a good choice. Minus 2y plus z equals negative 11. And the second statement is 3x plus 2y minus z equals 7. This is actually a very good choice because by picking this, you can see that there are some things, at least one set of items is going to cancel. When you add these together, the negative 2y and positive 2y, they're the same number with opposite signs. That's what we always want. We want the same number with opposite signs to get cancellation. So for the y values, I can see that these are both, this is negative 2, negative 2 and positive 2. They're going to cancel. And also, in addition, I look out even further. I have a positive 1z and a negative 1z, and those are going to cancel too. So this really works out great. If you add these together, you don't get cancellation, but that's okay. 3x plus 1x is 4x. Putting them together, I'm doing the elimination method. Elimination is where you add the two equations together, but you get at least one variable to cancel out. That's going to be your goal here. So here I have to add 1x and 3x to get 4x, so that's gone. I have the negative 2y and positive 2y. Those cancel out, so I look out there. And positive 1z and negative 1z, those also cancel out. So that I look out there too. So both y and z are both gone. And when you add negative 11 and 7, that's going to give you a negative 4. Now it's really easy. To solve for x, you can simply divide 4 on each side to get rid of the x using the inverse operation. I divide 4 on the other side as well. And when I divide negative 4 by positive 4, I'm going to get negative 1. So that's my x value. My x value is negative 1. So that's great. This one worked out really nice. I'm able to solve for x in one pass. All right. Now please note, when you're solving this, it's not just x you want. You need x, y, and z. So it's 3 different variables you got to find. So I use equations 1 and 2. Now I have to pick something else from there. Please don't pick 1 and 2 again because you'll just be going over the same ground. So you need to pick two equations, but not 1 and 3. So I'll let somebody else select from what remains. Anybody want to select from what remains? Again, you can't pick 1 and 3 because we chose that already. So you could pick any other combination though. Somebody else want to select a different combination?
2 and 3.
2 and 3. So let's take a look at 2 and 3. So if we take 2 and 3, 2 and 3, let's blow this up, give it more room. So 2 and 3 is 3x plus 2y minus z equals 7, and negative x plus 2y plus 4z equals negative 9. Okay. So I need to cancel out a variable. Okay. I need to cancel out a variable, but you also have the extra luxury of knowing what x is. So it's up to you as to how you want to go about this. You could get rid of x right now and put negative 1 in there. You know what? I think I'll do that afterwards. Let's try to eliminate a variable here. Um, don't eliminate x because you already know what x is. You need to eliminate either y or z, and it's kind of your choice.
Z.
You want to get rid of z? Okay, if we get rid of z, Just so we know, there's a negative. This is a 1 here, right? There's an invisible 1 there. So for z's, I have -1 and I have +4. Okay, I have -1 for the z and a +4 for this z. I need to have them be opposite signs, which they are. That's good. That one's negative, one's
Multiplied by
positive.
-4.
Multiplied by +4. Okay, the end. You want the end result to be -4. So if you multiply by +4, you're going to get a -4. Is that okay? Because remember, if you multiply this by -4, you're going to get a 4 and a 4, which won't eliminate. I need this to be -4. It's already negative. So if you multiply it just by a regular 4, 4 times -1 gives you -4. Is that okay?
Oh yeah, my fault.
You see it, right? Because if you multiply it by a negative, you're going to turn it into a positive. I don't want to do that. I just want to turn it into -4. It's already negative, which means I'm just going to multiply it by a +4, and that's going to do the job. But I know what you meant. So I'm going to multiply the top item by 4. Let me just change pens. So I'm going to multiply this by 4. Okay? Just this one. By multiplying this by 4, and we're going to do it, I have to do it this way because I don't. So I'm going to do 4 times 3x, which is going to give me 12x, right? Then I have to do 4 times 2y, which is going to give me 8y. Then I have to do 4 times -1z, which is going to give me -4z, which is what I need. I need -4z. And then last but not least, I got to do 4 times 7, which is going to give me 28. So please note, I'm allowed to do this because I'm multiplying the entire equation by a constant. That's legal. I'm maintaining the balance of the equation by multiplying the entire thing. Okay, both sides by 4. So that's why I get away with that. And the bottom one, I'm just going to copy. It's -x plus 2y plus 4z equals -9. And now when I go to solve this, it should work out nicely. Okay, if I add 12x minus, there's invisible 1 there, 12x minus 1x is going to give me 11x. 8y and 2y is going to give me 10y. The -4z and the +4z, this is what I wanted. I got cancellation happening, okay? So these cancel out. These are red. And then -28 minus 9 is going to give me 19. Okay? Now, you might be saying, hey, well, I can't solve this because there's 2 variables and I don't know how to solve it with 2 variables. Well, actually, you know what one of the variables is. You know that x is -1. So you can essentially take this -1 and -1 and place it inside x. So you can really say 11, you can replace x with -1 because that's the value of x, right? -1. I'm just taking this away. I don't want it to be confusing. So -1 goes in there, and this should allow us to solve for y. Okay? And when I work this out, 11 times -1 is -11. And then from there, I'm gonna add 11 to each side. I'm trying to solve for y, so I'm just adding 11 to get the 10y by itself, and that cancels out the 11s. And then I have 10y equals 30, right? Because 19 and 11 gives me 30. And finally, to get y by itself, I just divide by 10 on each side of the equation. These cancel. Divide by 10. And y is going to equal 3. So that's so far so good. I know my x value. I know my y value. I have my x. I have my y. I'm not done. I need to figure out z, and then I'm done. But that's easy. Once you know 2 of the 3 variables, then the problem's like really simple. to find z after you figure out the other variables, once you have two, to get the third variable, just go back up and you can choose any one of the equations you want to work with. It's up to you. You could choose 1, 2, or 3. You're only going to choose one of them because you know x and you know y. So you can just substitute in and figure out the third variable. Somebody want to select one of the equations to choose? It doesn't make a difference. No matter which one you pick, it should still give you the same value for z. So I'll let somebody choose.
2.
2? All right. So let's take equation 2. Equation 2 says 3x plus 2y minus z equals 7, right? And we know x is -1, so I'm going to replace x with -1. And we know y. We know y is 3. Replace y with 3. And we're trying to solve for z. So if we work this out, 3 times -1 is -3. 2 times 3 is 6, because multiplication occurs before addition, right? I multiply this, get this. 2 times 3, I get this. Minus z equals 7. I can put -3 and 6 together as +3. And now to solve for this, can I subtract 3 from each side? That looks good. Subtract 3 from each side. And then I have -z equals 4. Okay, and if -z is +4, then +z would have to equal -4, right? If I change the sign to solve for +z. If I change the sign on the left, I have to change the sign on the right, and then z would be -4. That looks like it's okay. It looks like everything's okay. Yeah, that looks about right. Okay, so that's it. You found all 3 points, all 3 values, x, y, and z. And when you answer the question, we're supposed to answer the question in like this, right? Normally you just answer x comma y, but because this is a triple ordinate, it's not just two things, right? It's not just x comma y, it's x comma y comma z. So in this case, x goes first, so it's -1, comma y should go next, 3, comma -4. And that would be your solution, -1, comma 3, comma -4. Okay, and that's it. Don't see anything else. Questions? Anything?
Is there a way to graph that?
Great question. Somebody in my one class asked me this exact same thing. Is there a way to graph this? Okay, so my answer is a little bit okay. Let me say this: with yes, but I don't have a way of graphing it for you with free software. But there is another way of doing this with technology, even though it's not graphical. We're going to use a matrice to do it, which I'm going to show you how to do on Wednesday. So essentially, what we're going to do is we're going to put everything we see here into a computer. And I have free software for this for doing it this way, so it won't give you a picture, but what it will do is it'll give you the solution. Okay, it'll give you the solution value, so you'll know what x, y, and z are. It gives you the answer. All right. So unfortunately, there's no picture, but we do get the x, y, and z value that work. So I hope that's helpful.
Mr. MPZ,
Yes.
can we use Desmos for this question?
Yes, you can, but I think there are probably I don't think Desmos is capable of graphing this. I think it'll just give you the solution as a triple as a x, y, and z, as far as I know. And doing it with Desmos, it's not so straightforward. So I have other free, like through the internet ways of doing it. Use a matrix calculator, and we'll put everything in. It doesn't. It takes like 2 seconds too. Right, it's really quick. But you have to be very careful with the information. It's got to go in a certain way. I'm going to show you how to do it on Wednesday, how to put this information in. Okay. another question through the chat. Oh, maybe not.
You go down.
Down. Sure. Is this okay?
Yes, thanks.
Sure. Let me let it sit here for a second. Anybody needs to copy anything. I'm
Wait,
gonna
so
yes.
is
Yes.
there questions with graphing like this, like a 3-step, whatever you call these
No.
type of questions? And
So in this
graphing.
course we're not gonna graph planes in this course. So remember, it's not really, these aren't lines, they're like planes in the it looks like this.
Okay.
These are planes, they're not lines. So that's why the stuff that you have, let me just go back so you can copy where that question go. They're, like I said, they're not lines. All right. So this one, the technology that you have, even if we were in the building and you had a TI-83 calculator or 84 calculator, it's not capable, as far as I know, of graphing this type of thing. But that's okay. You don't need to. You don't need to. You don't have to graph it. You can do it with a matrice, which will calculate it for you in a much faster way than doing it manually, which I'm going to show you Wednesday. The only thing is, on the actual state exam, you could be asked to show all the work. So unfortunately, even if you use the technology and get the answer, we're still going to be responsible for knowing how to solve it algebraically. All right. So that part, that can't be helped for the state test. I don't get to make the rules on that, right? They create that. So that's what they usually say. If it's multiple choice, then you're set, because then you can just use the calculator and it's simple. But if it's not, and it's in the open response questions, it'll often say only an algebraic solution will be accepted. So then unfortunately you have to be able to work it out. Sorry. I would still use the calculator to get the answer though, and then do the work. All right. I'm gonna do most of the examples on the state exam are ones like this where you can solve. See how I have an answer. -1, 3, -4 is the answer. There's a solution value. There's one solution. That's how most of the questions will look. However, there are special cases. There are two special cases. There are cases where there's no solution, and then there are cases where there's many solutions. And of course, I'm going to take you through both. So I'm going to do example 2 first, which has no solutions. I want you to see how that looks, because when you look at it, you might not know, and you shouldn't know just by looking at it, that it has no solution. You're not going to know that. You won't know that until you attempt to do the problem, or if you use technology, you'll see that, oh, it can't be done. So let's pretend it's a Regents question. It's in the back of the booklet. So technology will just give us the answer, but it won't give us any points because we have to show all the work. So, all right. So we use a computer. We see there's no solution. Okay. There's no solution. The calculator says error or something like that. There's no solution. So now we know that, but they won't give us any credits unless we show the work. So we're going to show the work. So I'm going to do the same thing I've been doing in the other example. I have equation 1, equation 2, and equation 3. So you could use substitution, but I'm going to stick with elimination for consistency today. So I'll let somebody tell me, I'll let somebody tell me which equations they want me to work with. And it's your choice. You need to pick 2 equations though to work with. I will grant you some equations are easier than others, but I'm going to let you have the freedom of choosing what you want to choose. So somebody tell me which ones they want me to start working with first, and I'll start with what you guys tell me.
2 and 3.
2 and 3? Okay. So if we look at 2 and 3, 2 and 3, 2 is 5x plus 5y plus 5z equals 3. And 3 is 4x. So this choice is not going to give us any cancellation immediately. So we're going to have to do some work. Minus 3z equals -6. Okay, so if I put these together, I'm not going to get any cancellation. All right, if I add 4x and 5x, that would be 9x. I don't get a cancellation. 5y and 1y, there's an invisible 1 there, no cancellation. And 5z and -3z is no cancellation either. So adding these together provides me with no cancellation. However, I could still work it out. We need to pick a variable to work with. We can work with x, y, or z. Now, bear in mind, if you pick x to work with, you're going to have to find something for 4 and 5 to fit into. That's kind of annoying. If you pick Z, you have to find something for 5 and 3 to fit into, which isn't so bad, but it could also be a little annoying. If you pick Y is actually the easiest one to pick because with Y, you have 5 and you have 1, and 1 can become a 5, right? And the other choices, they're tougher. But I don't want to lead you too much. I want to let you pick. So I'll let somebody tell me which variable they want to work with, and then we'll try to eliminate or kill or destroy that variable. So
Why?
yeah, Y is easier. So Y has 5 in one of them, right? And it has 1 in the other. Okay. So I can turn 1 into a 5. How do I turn 1 into a 5? What do I do to it? How could I turn it into a 5? Anybody have any suggestions? How do I turn
And
1 into a
multiply
5?
by 5, but it has to be a -5 because you
That's correct. So I'm going to actually not multiply. You are correct. I'm not going to multiply it by 5. I'm actually going to multiply it by -5. By doing that, I'm going to have 5 in the top equation, and then -5 times 1 is -5. That's going to allow the variables to cancel out. So that's smart. You're going to want to multiply the 1 down here by a -5. Unfortunately, you can't multiply what you want, just what you want. You got to multiply the entire equation. So I have to multiply the entire bottom equation by -5. And I get to leave the top equation alone. So I'm just going to rewrite 2, which is 5x plus 5y plus 5z. No work is happening. I'm just recopying what I have. No work. Now I have to listen to what he suggested and multiply the equation 3 by -5. I have to do that. So I'm going to do -5 times 4. And -5 times 4, or 4x, I should say, is going to be -20x. That's first. Then I have to do -5 times 1y. -5 times 1y is -5y. I'm happy about that. It's going to help me in a minute. I got to do -5 times -3z. -5 times -3z is positive 15z. And lastly, -5 times -6 is positive 30. Questions, or are we okay? Anything, or we're good? We're good?
Okay.
All right, great. And now we can add these together, right? If I do 5x minus 20x, that's -15x. And I'm happy because the positive 5y and -5y, I'm going to get the cancellation I want. Those go away. So that's great news. And then here I got 15z and 5z, which is 20z. And then I got the 3 plus the 30, which is 33. So that's the best I can do, okay? Notice we've eliminated y, all right? So we only have 2 variables in this equation. So that's good. Okay, I chose equations 2 and 3, and now I have a new equation. I got to do this again. You can pick anything you want, but you can't pick 2 and 3 again, or you'll be wasting your time because you already chose 2 and 3 here. So I'm going to have somebody choose 2 equations, right? So what's left? You could either pick 1 and 2 or 1 and 3. Those are your only options because you chose 2 and 3 already. So somebody want to pick something?
1 and 3.
1 and 3?
1 and 3.
Okay. Yeah, 1 and 3 works. Either way, if somebody else picks 2 and 3, it's still going to work. I mean, or 1 and 2 will still work. So x plus y plus z equals 2. And by the way, there are invisible ones in front. If you want to write the one in front, you can. If you don't want to write the one, you don't have to. It's your choice. So 1x plus 1y plus 1z is 2. And we chose 3, which is 4x plus 1y minus 3z equals -6. Okay, let me just move those 1s and 3s over because they're kind of in my way. These, just move them over a little bit. So 1 and 3. Oops. Okay. Okay. So before I killed off or I destroyed or eliminated, the real word's eliminated, I eliminated y. So I have to eliminate y again. Okay, I had to be consistent. If I eliminate y over here, I have to eliminate y over here as well. Okay, because the new equation I have is in terms of x and z. I need the equation that comes out of here to be in terms of x and z. So I have to eliminate y. I have to eliminate y. Well, let's look. The y for the top equation is 1. The coefficient for the bottom equation for y is also 1. These aren't going to cancel out. If you put 1 and 1 together, you're going to get 2. So it's not going to eliminate. I need, if one value is positive 1, what do I need the other one to be so that it goes, so that I cancel it out? What would I need?
Negative.
Correct. It needs to be negative. So how do I turn a positive 1 into a negative 1? How do I do that?
You multiply it by -1.
That's correct. You multiply it by -1. Again, you multiply it by -1. And it's your choice. You can multiply the top one by -1 or the bottom. I'll choose the top, but it doesn't make a difference, all right? Please don't do both. If you multiply both of them by -1, then you'll have -1 up here and then -1 down there. And then you have then you have another problem. You have 2 negatives that won't go away either. So just do one of them, all right? Just multiply one of the equations, not both. So I'm multiplying the top one, and yes, could you have chosen the bottom? Yes, you could have. It doesn't make a difference. You'll get the same answer regardless. Please note, there are about 20 different ways of solving this problem, okay? So it's not likely, it's very unlikely that 2 people are going to solve it the exact same way. That's very unlikely, okay? Usually there's going to be some differences, and that's okay. At the end of the problem, we're still going to have the same answer if we do it right. So let me multiply this. I have to multiply this by this, then this, then this, and then this. So -1 times x. -1 times 1x is -1x. And then -1 times +1y is going to be -1y. -1 times +1z is going to be -1z. And -1 times +2 is going to be -2. So all that really happened is all the signs changed. And the bottom equation 3, I'm not going to mess with. I'm just going to leave it as 4x plus 1y minus 3z equals -6. Okay? And now I want to add these together, and let's see what happens. If we do 4x minus 1x, that should be 3x, right? -1 plus 4 is +3. Look at these cancel out. So we wanted that. We got what we wanted, the -1y and the +1y. They eliminate. That was the purpose. And when I put these together, that's -3z and -1z is -4z. And -2 and -6 is -8. Okay? So now I have 3x minus 4z is -8. So let me just erase these ones that are in my way. And now look, this equation is -15x plus 20z equals 33. We solved that earlier. And now we just solved this one, which is 3x minus 4z equals -8. I'm very happy so far because you've gone from 1, 2, 3 equations with x, y, and z, 3 variables. So 3 equations with 3 variables down to 2 equations with only 2 variables, okay? Now you only have x and z, you have 2 variables, and you only have 2 equations. So you've converted a question that that you didn't know how to do, you converted it into a question that you do know how to do. So all this work here, all of this and all of this is to convert this 3 variable, 3 equation question into a 2 variable, 2 equation question. That's the point of doing all this, okay? And now this should not be very, very hard to solve. So it's your choice. Okay, this is like the homework questions now. You can pick either X or Z to work with, and we have to eliminate one. Somebody want to tell me which one they want me to work with? I don't really see much of a difference. The difficulty is the same, so feel free to select
Z.
what you want. Z? Okay, so if we're going to get rid of Z, we're going to destroy Z. Z has 20 for this Z, right? And -4 for the other. So I'm happy because one's positive and one's negative. That's good news. But 20 and 4, what could I use? Well, I think 4 can become 20, right? How can I convert this 4? How could I
Multiply
make
by
this?
5.
That's correct. Multiply by 5. If you multiply this -4 by 5, if you multiply this by 5, you're going to have 20 and you're going to have -20, which we know will eliminate. So I have to multiply the one with the -4, the bottom one, this bottom equation here, by 5. So I'm going to multiply this equation down here by 5. Okay? That is not the only way to do it. You could have multiplied this by actually by -5. If you multiply by -5, you'll be eliminating the x's instead. Okay. So let me see here. The top one I'm leaving, -15x plus 20z equals 33. I'm not touching the top. The bottom one, 5 times 3x. I have to work that out. That's 15x. Then I have to do 5 times -4, which is going to give me -20z, which is what I wanted. And finally, I have to do 5 times -8, which I believe is -40. Okay, so now I'm ready to add these together. So I actually this one kind of weirds out. -15x and +15x, those are going to cancel out. And what you wanted, the 20z and -20z, those also cancel out. So it turns out that everything on the left is gone. There's nothing left. Zero. There's nothing there. On the right side, so everything on the left is gone. 33 minus 40 is -7.
So no solution.
That's correct, okay? Because we have a constant on the left side, constant 1, which is 0, which is not equal to the constant on the right, which is -7. These are different values. The 0 and -7, they're never equal. It's a false statement. So because we get two constants that are different listed as equals, right? That's a lie. That's not true, right? 0 and -7 are not equal. So since that happens, that means that there's no solution. So we knew going in that this was no solution. All right. I'm just going to take this away because it's not relevant. So there's no solution. Okay. I have one last thing to start, and then I didn't finish question 3 in my other class either, but I started at least. I want to start it. I'm sorry that we're 4 or 5 minutes behind. That's my fault because I had to take care of something with programming, so that took me a couple of minutes. But let me just start this problem off, and we'll finish at 11:30 on time. Okay, I'm sorry. Were there any questions? Anything?
No.
Awesome. Anybody else? Okay, before I do the next question, I'm going to start in a second. Um, a few people have asked me from my other class if I could stay around for a little bit of help, and I have some time today. As far as I know, I don't have a meeting. As far as I know, so at around 2:15, I'll set up a section. If you're interested for any extra help, any questions you want to ask me, then please send me email so I know to put your name in there. I don't do teaching in there. You could just ask me questions about anything you want, and then I'll just do an example of it. Okay. So it's whatever that you want to look at. If you have a question with the homework problem or something like homework number 7, number 3, we can look at it and I'll help you go through it. Okay. So I'll set that up today. I can only do those sessions on usually Fridays, but every now and again on Monday too. But for me, Wednesday and Thursday is impossible, and Tuesday because I teach. I have a college now class on Wednesday and Thursday. Like definitely, I can't do it on those days. Okay. Let's start 3. Let's at least start 3. This one's gonna have many solutions, so it's gonna look weird at the end, but let's start it at least. So I'm gonna do the same thing I always do. Okay, I'm gonna label, I'll use green. Equation 1, equation 2, and equation 3. And you can select which ones you want to work with. Anybody want to just throw out an equation? What do you guys want to work with?
1 and 2.
1 and 2? Okay, let's do it. 1 and 2. So 1 and 2. So equation 1 is x minus y plus z. Good choice, by the way. Equals -3. And the other one is x minus y minus z equals -3. They almost look identical. There's a subtle difference there, though. Okay, for good measure, these all have, right? These are all 1. So if you want to put the 1 there, feel free. If you don't have to. It's your choice. This is actually pretty nice because I think I could add this together the way it is. If you look at it, positive 1z and negative 1z are going to cancel out. So I don't have to adjust anything. This is good to go as it is. Okay. Oh, wait, did you say, okay, wait, 1 and 2. Okay. So this is good to go as it is. I can just add this together right now. I don't have to change anything. If I add it together, 1x and 1x is 2x. Negative 1y and negative 1y is negative 2y. And look at this. The positive 1z and negative 1z cancel out, so I'm happy there. That's good. And when you add -3 and -3, you get -6. Okay, so that's statements 1 and 2. And by picking statements 1 and 2, we got rid of z. So now I have to do this again, but I can't pick 1 and 2 again. So somebody else want to pick something different? Anything but 1 and 2, because you already have 1 and 2. So somebody select something.
2 and 3.
2 and 3. Okay, 2 and 3. 2 and 3. If we select 2 and 3, we have 2 is x minus y minus z equals -3. And we have 5x minus 5y plus z. This is a good choice. Equals -15. Now, bear in mind, right? Bear in mind, we have to kill z off or eliminate z. Because we eliminated z the last time, I had to eliminate z this time. And this was a good choice because if you think about this, right, these are all 1s. Look at the z's. One's positive 1z, the other's negative 1z. These are going to eliminate again. So I don't have to do any multiplication. All right, you got, these are great choices that people made. I could just add these together as they are, and the z's are going to go away, which is great news. So if I add 1x and 5x, I have 6x. If I add -1y and -5y, I have -6y. And this was a great choice because the -1z and positive 1z are gone. And I have -3 and -15, which is -18. So the first equation has x and y, and this equation now only has x and y. So I'm not going to finish this. I'm just going to write them down. 2x minus 2y equals -6. That's one equation. That's this. And the other one is 6x minus 6y equals -18. All right. So I'm going to stop here. You have two equations. At this point, you should be able to figure it out. It's like the homework assignment I gave you. You're solving a system of equations with only two variables. At this point, you could actually graph if you wanted to. You could actually graph these because they're in terms of x and y, only two variables. So I'm going to leave this here. It's exactly where I stopped my other class. We're perfect place. And try to do this one, finish this up on your own tonight. And then tomorrow we'll look at it. There is a homework assignment, but it won't be due till Wednesday night because I still have to do 2 more days of this. All right. I don't want you trying. I mean, you could try to start, but you haven't done that many questions with 3 yet. So it might be a little challenging right now, but you can try. Let me stop there because I'm going to be respectful of your time. If you have any questions or you want to attend the class later today, please email me. I only